Hello and good day, pre-algebra. We are covering CO45, which is using something called partitive proportions. Okay, and what partitive proportions do is they divide a total into proportional parts using ratios. Okay? They divide a total into proportional parts using ratios. So it kind of goes back to our initial objective for the unit, PO39, talking about ratios. We learned that ratios took something and divided it into parts. Okay? And we use equivalent ratios, built our way to fractions and proportions, and here we are kind of combining those two concepts here. Right? So I'm going to skip this introduction here because I think verbally is going to be better explained than reading that. So we've got 64 things. It says divide 64 into two parts in a ratio of 1 to 3. Okay? Divide 64 into two parts in a ratio of 1 to 3. Remember when we use equivalent ratios back at the beginning? And we talked about, kind of like what is the total of our ratio? 1 to 3. How many things are we talking about there total? Remember, we added these to get that total. The sum of 1 and 3 is 4. Come on, people, let's go. The sum of 1 and 3 is 4. Okay? And so what we want to do with that 4, the reason why that 4 matters, okay, is we're going to take that 4 and divide our total by that number. Because what that's going to tell us is how many are essentially our unit rate here. Okay? 64 divided by 4 is 16. Yes? Okay? So this ratio of 1 to 3 here, if a unit is 16, 1 times 16 is 16, 3 times 16 is 48, and there is our final answer. Okay? We've got a total of 64 divided into a ratio of 1 to 3, 16 to 48. Does 16 plus 48 equal 64? Yes. So we know that we have everything accounted for here. Okay? If I did my multiplication wrong and I thought that 3 times 16 was, 52, and I added 16 and 52 together and realized, oh, wait, that's not 64. Okay? I would know that I made a mistake somewhere along the way. Aiden.
You're just trying to find what is like 1 to 3 of 64?
Right. That 1 kind of represents 1 unit. That 3 represents 3 units. We want to figure out what that unit is. Okay? And to do that, we add these together, 1 and 3, divide our total by that number, and that 16 represents what that single unit is. So 1 of them, 16, 3 of them, 48. Okay? The next one, 600 in two parts with a ratio of 11 to 13. Again, we want to kind of figure out what the value of 1 unit is. So we're going to take our 11 and 13, we're going to add them together. Whoa. Almost wrote 11 plus 11 there. 11 plus 13 is 24. What do we do with that? Now, yeah, Annika. Divide our whole, our 600, by 24, because that's going to tell us the value of 1 unit. I don't think this one works out evenly. Oh, it does. I stand corrected. 600 divided by 4, or divided by 24 equals 25. Okay, that's the value of a solitary unit. What we want to do is we want to divide 600 into a ratio of 11 to 13, meaning we want 11 units and 13 units. So we've got 11 to 13. Each unit is worth 25. So 11 times 25, 275. 13 times 25, 325. Okay? We're adding the parts of our ratio together, dividing the whole by that number to get the value of 1 unit. And we're saying, okay, I want 11 25s and 13 25s, which is a total of 275 and 325. Do those add up to be 600? Yes, they do. So you know that we've done that correctly. Okay? The third one, divide 450 into 3 parts in a ratio of 4 to 5 to 6. The process is the same here, right? If we want to figure out the value of 1 unit, we have to add 4, 5, and 6 together. 4 plus 5 plus 6 equals 15. What do we do with that? What do we do with that? Connor? Take our whole and divide by 15 because that's going to give us the value of 1 unit. And we can use that to put it in the ratio of 4 units to 5 units to 6 units, right? So it kind of goes back to unit rate a little bit. And we want to figure out what 1 of something is. So 450 divided by 15 is 30, which means we want 4 30s to 5 30s to 6 30s. So 4 times 30, 5 times 30, 6 times 30 gives us 120 to 150 to 180. Okay? Notice how our original ratio 4 to 5 to 6 increases by 1 from 4 to 5 to 6. Since 1 unit is worth 30, that's why our final answer, it increases by 30. 120 to 150 to 180, right? Because each one of the ratio represents 30. And we found that by doing this step here. Okay? Here's some application of it. Let's jump over to the second page here so you can see how this actually applies. Right? And let's look at the second one. In an orchard of 2,000 trees, there are peach, apple, and pear trees planted in the ratio of 5 to 3 to 2. How many trees of each kind are there? If you run an orchard, why don't you just plant the same number of each kind of tree? Why would you might want more peach trees than apple trees to pear trees? Why would there be a difference there? What do you think? Yeah? Maybe you get more profit from a peach tree. Okay? Maybe pear trees are super expensive. Maybe people come to your orchard to buy more peaches than anything else, right? So it's a business decision here, perhaps, why we have more peach than apple or pear. Aiden?
I have a question.
Yeah.
For the 2-part ones,
Mm-hmm.
I only have 2 of them. Could you technically just figure out the first one and then minus that from the total of it?
You could. If that's more of kind of a guess and check way to find it, but yes, that would be another option. Okay, so these peach trees, 2,000 total, peach, apple, pear, are planted in a ratio of 5 to 3 to 2. Right? We want to figure out what the value of 1 unit is. How many trees does one of that 5 represent, or one of that 3, or one of that 2? So just like before on the first page, we're going to add these together for 10. We're going to take that 10, divide the whole by 10, and that gives us 200. What that tells us is that each unit of that ratio represents 200 trees. Okay? Each unit of that ratio represents 200 trees. So if the ratio is 5 to 3 to 2, each unit representing 200, 5 units of 200, 3 units of 200, 2 units of 200. You can also think about this as scale factor, right? That's kind of also what we're finding here, the scale factor. How do we get from 5 to 3 to 2 to the actual amount of trees? We're finding that scale factor of 200. 5 times 200 is 1,000. 3 times 200 is 600. 2 times 200 is 400. Does 1,000 plus 600 plus 400 equal 2,000? Yes, it does. We have all trees accounted for. There are 1,000 peach trees, 600 apple trees, and 400 pear trees. Okay. We can also take this one step further, and we can notice that the first number of our ratio, that 5, is the same as the second two parts, 3 and 2. Right? 5 is the same as 3 plus 2. So it makes sense that there is the same number of peach trees as apple and pear together, right? Because our base ratio, 5, 3, and 2, 5 is the same as 3 plus 2. So those relationships that exist in the original ratio also exist in the actual totals. Okay? Any other questions on this one here? No? This is really great for when you go out to dinner with friends. Probably once more you get to high school and you get your driver's licenses, you'll get to meet up at places and go out to dinner. And let's say that you're not very very hungry. You order 3 tacos, and then your friends, one orders 8 tacos, another orders 20 tacos, and then the bill comes and all right, let's just split it evenly. What? No, I only ordered 3. You ordered 20. How is that? Why should I pay the same amount as you? That doesn't make sense. This is a way that you can kind of divide that bill evenly. Okay, as we have here with Chris, Tamara, and Grace. They sent a package that costs $124.20 in shipping. I'm underlining that because that's our whole. If Chris's part of the shipment weighed 5 pounds, Tamara's weighed 3 pounds, and Grace's weighed 12 pounds, how much should each pay? Would it be fair to divide that $124.20 by 3 and have each of these people pay the same amount of the shipping? No, right? Poor Tamara there might have something to say about that. Her part of it was only 3 pounds, whereas Grace's was 12 pounds. Grace should pay the most, right? Even Steven, fair. Okay, so what's our ratio here? We've got 5 pounds, 3 pounds, and 12 pounds. That's what's going to make up our base ratio. And we're essentially looking for the value of each unit, or the scale factor here, so we can divide the shipping costs up evenly. 5 plus 3 plus 12 equals 20. What do we do with that? What do we do with that? Aiden?
Divide $124 by 20.
$124.20. Okay, we're going to divide that by 20 to get the value of 1 unit, or to get the value of the scale factor. So 124.20 divided by 20 is $6.21. Okay, that means that for every pound that each person is responsible for, they should be paying $6.21. So Chris, whose part of the shipment is 5 pounds, he should be paying $6.21 5 times. Tamara, whose responsibility is for 3 pounds, should be paying $6.21 3 times. And then Grace, who's got the most, she's got the heaviest part, 12 pounds, she's paying that $6.21 12 times, right? So by adding these parts of the ratio up to get that 20 and dividing that by our whole, what this essentially means in context here is you're paying $6.21 per pound. And so 5 pounds times $6.21 is $31.05. That's Chris's. 3 pounds times $6.21 is $18.63. That's Tamara's. And then 12 pounds times $6.21 is $74.52. That is Grace's portion. A much more fair way to divide this up rather than just dividing by 3 because there are 3 people, we all pay the same. Not quite so much here. Okay. Questions on this? Yeah, John.
You got 20 from, did you get 20 from 12 plus 3 plus 5, right?
I did.
Wait. Oh, no, never mind.
Yep. Yeah, if we add the total weight together, okay, there's 20 total pounds, and divide that by the whole, that's going to give us the price per pound here. And we take that unit, that price per pound, and multiply it by each part in the ratio to get what each person should pay. Okay. Other questions on this? Okay. Some other real life examples here of what's going on here. A man raised $81,000 for his son's middle school and high school. For every $5 he gave the middle school, he gave $4 to the high school. How much did he give to each school? So he didn't divide that $81,000 evenly. He gave a little bit more to the middle school than he gave to the high school. So how much did he actually give? Andrew, Andy, and Drew started a business, investing $6,000, $9,000, and $10,000 respectively, meaning that Andrew invested $6,000, Andy invested $9,000, and Drew invested $10,000. They plan to split the profits in the same ratio. You know, Drew here, who invested the most, should get more of the profits, right? He put a bigger risk out there compared to Andrew, who invested the least. You know, still should get some profits, but not as much as the other ones. So what will each person's share be if the overall profit is $84,000? Okay, same idea, same concept here as the 2 that we did together and the 3 we did on the first page. And then in order to maintain financial responsibility, you decide that for every $100 you make, you'll give $10 to the church, put $45 into savings, put $27 into a college fund, that's important, and keep $18 to spend on whatever you want. How much will go into each place if you make $900? Okay, so what this is saying is that if you make $100 exactly, that much money goes into each of your 4 places. So if you make $900, 9 times that, right? How much will go in each one? And then 1 month you keep $90 to spend on whatever you want. How much did you make that month? And then the second part, the next month you give $125 to the church. How much did you make that month? Let's talk about this first one here because it's different from the others. Here I'm giving you one of the parts. Okay, this uses the same kind of breakdown as we have up here. So if you keep $90 to spend on whatever you want, let's kind of write these ratios out. $10 for the church, $45 into savings, $27 for college, and $18 to spend on whatever you want. Okay, for every $100 you make, that's how you divide it up. 10 plus 45 plus 27 plus 18 equals 100, right? So 1 month, you get to keep $90 to spend on whatever you want. Which number does that $90 associate with? Does that $90 refer to the 10, the 45, the 27, or the 18 here? Which one is it connected to? If it's to spend on whatever you want. Yeah. The 18, right? And the question is, how much did you make that month? Well, if for every $100 you put 18 into whatever you want, spend on whatever you want, but this month you put 90, how can we answer that question of how much we made in all? What's the scale factor between 18 and 90? 5, right? So you essentially put 5 times as much into the whatever you want portion. And so if you put 5 times as much, what does that mean that you made overall? For every $100 you make, you put 18 into spending on whatever you want. So if 1 month you put 5 times that, 90, into spending whatever you want, what does that mean you made that month? $500, right? 5 times the whole. That scale factor is consistent throughout. If you put 5 times that amount of money into spending whatever you want, that means you made 5 times your base ratio, that base amount of $100. So you made $500. Yes, Aiden?
I have a question.
Yeah.
For like the original one, not like the Brainbuster one below it, do you want us to like do it the way you just taught us? Can we just do it like you multiply every one of the numbers by 9?
As long as you show your work, what you're doing, then yeah. And in fact, multiplying each of the numbers by 9 is exactly what I would want you to do, right? Recognize that, in this case, for this question here, if your base ratio is associated with $100, but you make $900, what's the scale factor? 9, which means you're going to put 9 times the amount to the church, 9 times the amount to savings, 9 times the amount to college, and 9 times to spend on whatever you want. That's exactly what I want you to do. Yeah. Okay? All right. So, in honor of National No Homework Day, this is not going to be homework. However, do not put it away because you have 8 minutes left of class to work on it now, and you must be working on this during that last 8 minutes. So it's not homework, it's end of class work. There's the difference. Yes? You may not do con right now. I want you to work on this. That's my deal for it not being homework. We'll work on it for the last 8 minutes now. Aiden.
What if you finish it in the last 8 minutes?
Then you can work on con. All right. So your test is going to focus mainly on these word problems here. So I would start with this. It's sometimes a little bit easier to do it when you've got context, but the first page and the second page ultimately are what needs to be finished. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? All right, folks, that's all your math.